Hello. I wanted to send you some of the solutions to the math packet that many of you worked on this summer, and continue to enrich yourself and think logically about math. So let's look at the first one. I noticed as I talked to a few students that the first one became a guess and check problem. Let's look at it a little differently. Let's look at it more as a pattern. If I look at the numbers 1, 2, 3, 4, and 5, and I say, well, wait a second. If I notice that 1 plus 5 is 6, 2 plus 4 is 6, that leaves me with the number 3. So 3 must go in the middle. So we could do 5, 3, 1, 2, 4. Then hopefully we recognize that, well, that's not the only possible solution. There's many solutions. We also could say that 2 plus 5 is 7, 3 plus 4 is 7, so that can leave us with 1 in the middle. That's our leftover number. We also could say, well, wait a second, we used up the number 1. Is there anything with this? 1's an odd number, 3's an odd number. Wait a second, 5's an odd number. So could 5 be the middle number for the next one? Well, if we look at this, we notice that 1 plus 4 is 5, 2 plus 3 is 5. So we could have 1 and 4, 2 and 3. So then we add these numbers vertically and horizontally, they all give us the same solution. Now, as we move to the bike shop problem, I personally think setting this up as a table is the easiest way to do this. It's not the only way to do it, but I think it's the easiest, so you're not guessing and checking. So if I had 10 tricycles, that would be 30 wheels. Then I'm going to have no bicycles. If I had 8 tricycles, that'd be 24 wheels. So then I need 6 more wheels. That'd be 3 bikes. Well, if we start to notice something, there's a pattern that's forming as we solve this. So if you notice, on the top, okay, if we look at every 2 tricycles, so we went with 10, then we said, okay, well, let's look at 8, let's look at 6, let's look at 4, 2. The trouble is if we only have 1 tricycle, that's an odd number of wheels, and there's no unicycle we could use to be looking at as a sale item in our bike shop. So then with bicycles, we're counting every 3. So 3, 6, 9, 12. So then we know that here, well, if there's 15 bicycles, that's also 30 wheels. Now, the ANA problem in relationship to 37 cents, I'm only going to give a couple of these. There is multiple possible solutions here. But again, setting up as a table, so I know I have a penny, I have 5 cents, I have 10 cents, I have 25 cents, or I have a penny, a nickel, a dime, and a quarter. And when I start to break this down, well, to have 37 cents, I know I'm going to always have to have 2 pennies. And I could keep writing 2 pennies multiple times. But wait a second, if I had 2 pennies and 7 nickels, I don't need to have a dime and a quarter to have 35 cents. If I have 2 pennies and 5 nickels, well, then I'm going to have 1 dime to make 35 cents. If I have 2 pennies, 3 nickels, that gets me 20, wait a second, that gets me 17 cents. So then I'm going to need 2 dimes. Again, no quarters. So as we start to look at these different combinations, there's ultimately multiple more ones you could come up with. As we look at our product problem, we have to remember product is 2 numbers multiplied together are 96. So if I think of the factors of 96, so I say, well, wait a second, let's create a factor tree. So we say, okay, what times what is 96? So remember, 2 whole numbers. So we know that 1 times 96, but the trouble is, wait a second, their sum has to be less than 30. Well, 1 and 96, if I add those together, that's 97. That's not less than 30. Wait a second, what about 2 and 48? That's 96, but not less than 30. What about 3 and 32? What about 4 and 24? Look at 6 and 16. Look at 8 and 12. So wait. I know that 4 and 24, that's a solution, right? That could be the two of the numbers because that's less than 30. We know 6 and 16 is less than 30. We know 8 and 12 is less than 30. So as we look at the number 5, I only did obviously 2 rectangles. I would love to see the number of different rectangles that children came up with, especially if they're willing to use fractions. I mean, obviously it becomes an endless number of possibilities. But, so I did one rectangle where if we had dimensions 4 by 8, so that'd be 32 square units. That'd be a perimeter of 24 units. I did another, there's 2 by 16, that'd be 32 square units as an area, but the perimeter of that would end up being 36. For number 6, draw and label a quadrilateral has a perimeter of 48. So if we have a perimeter of 48, well, if we add up 16 plus 8 is 24, 24 plus 24, 48. Okay, there's our perimeter. What's the area? Well, the area would actually be 128 units squared with that one. Again, multiple different solutions. Number 7 is interesting because number 7 really piggybacks off, if we remember correctly in the first problem, the odd numbers were the numbers that we end up sharing. And so if we think about sharing, we can think about putting them into these categories because those are shared numbers. So if we let 4, 6, and 2 not be shared because they're even, but if we allow ourselves to say, well, wait a second, we can share 1, 3, and 5. So if I know if I did 4, 5, and 2, that gives me a total value of 11. If I do 2, 3, and 6, it gives me a total value of 11. If I do 6, 1, and 4, it gives me a total value of 11. And that's one possible solution. My question would be, is that the only solution? Okay? For number 8, I apologize. I think it's a little confusing. When I say that 4 people can sit at one table, what I'm referencing here is the idea that we would have somebody seated on each side of the table. So that when 2 tables are pushed together, it would look like that. So if you did not recognize that, please stop this now and go back and try to solve number 8. If you did recognize it this way, then obviously there's no reason to stop it, and we can go on to look at the solution. So as we're looking at the solution, I might just say and set up as a table. So I said, okay, table T P people. So 1 table holds 4 people. 2 tables hold 6 people. So if I said to you, how many tables must be placed together in a row to seat 10 people? Well, I said, okay, well, here's 10 people. Sorry. So we know that 4 tables seat 10 people. Then we know that 20 people, so we go down and we say, well, wait a second, we finished our table, we know we're 20 people takes 9 tables. Now if we said if tables are placed together in a row, how many people could be seated using 10 tables? Well, 10 tables would have 22 people. Now if we kept this chart going, we know that 15 would seat 32 people. Number 9 is an interesting one because what I love about it is, although it's not written out as a model drawing problem, I think it's easily solved as a model drawing problem. Lisa, Julie, and Tom. So we know that each one of them, and remember with model drawing, we each start with a unit bar that's comparable. So Anton would like to know their ages. Tom gives him the following information. He says, I am 7 years older than Julie. So Tom is 7 years older than Julie. Lisa is 9 years older than Julie. If you add our ages together, you will have my mother's age, which is 40. So what I like about this is it's just organizing our information. So we know that we have 3 ages that we have 3 boxes we have to fill in because we're not sure. So we're saying, well, that's 16, so if we take 16 away from 40, that leaves us with 24. We're dividing 24 by 3 because we have 3 boxes left. So that means that's 8. So if we allow each one of these to be 8, then we know that our ages are, so we have an age for Lisa of 17, we have an age for Julie of 8, and we have an age for Tom of 15. I find as I do the single file line one, or any problem of this nature, I like to, same as if you think about probability problems, they play out this way too. We're saying, okay, well, I know I have 7 people that are lined up. And right off the bat, they tell me there's 2 children between Charles and Danielle. So I'm like, okay, well, wait a second. I have to make sure there's always 2 spaces. Okay, so I could have Charles and Danielle. Wait a second. So for me, if I put Charles and Danielle like that, there's a trouble. That's not 2 spaces apart. That's only 1 space apart. So let's go back and say, well, wait a second. What if we moved Danielle over? And then we get to the next time. Say, Emile, the smallest, takes the hands of Danielle and Francois. They're the same number of children behind and in front of Bernadette. Well, if there's 7 total children, well, this is the middlemost. We have 3 on either side, right? There's 3 there. There's 3 there. Then we say George is one of the children in line in front of Andre. So if Andre is here in line, and I'm assuming the line's facing this way, George is here, that's one possible solution. Out of curiosity, I would love to see if you got that solution, that's great. I'd love to see, is there another possible lineup that would allow all of these statements also to be true? When I look at the problems like this, again, I think setting up a chart can be very helpful for the flower deliveries. So you just have a starting place. So we know we're talking about certain people, we're talking about certain types of flowers. So we have red carnations, we have yellow carnations, we have red tulips, we have yellow tulips, we have white daisies. I'm just going to write daisies because we only have one type of daisy. We know that Mrs. Dolan, so we have Dolan. Mrs. Culleton lives in Austin. Well, that's nice for Mrs. Culleton. Mrs. Hunt and Miss Ballin, right, want yellow flowers. Mrs. Robinson and Mrs. Hunt want carnations. So let's go back and think about this. Miss Dolan only buys red flowers. So she can only buy either red carnations or red tulips. Then Mrs. Culleton lives in Austin. That's irrelevant to us. We just know that she's getting flowers. It's really, we don't care. Mrs. Hunt and Miss Ballin want yellow flowers. So wait a second. Yellow flowers. So Hunt and Ballin want yellow flowers. Mrs. Robinson and Mrs. Hunt want carnations. Wait a second. If Mrs. Robinson and Mrs. Hunt want carnations, doesn't that help us start to realize the connection, the overlapping person is Mrs. Hunt? Because Mrs. Hunt wants yellow flowers and she wants carnations, and she only wants a yellow carnation. So we can safely say that the yellow carnation goes to Mrs. Hunt. And then from there, I would hope you could fill in the rest. So I want to give you a chance, if you didn't do it this way, to finish this off, and then I will give you the solution in a second. Okay, so as you start to break it down, hopefully you recognize that Miss Dolan's going to end up with red tulips, Miss Culleton will be the white daisies, Mrs. Hunt will be the yellow carnations, Mrs. Ballin will be the yellow tulips, and Miss Robinson will be the red carnations. Okay, I went ahead and did out the solutions here. The trouble with number 12, and this was not purposeful on my part, I apologize, is I know that we were briefly exposed to exponents and factorial. The third grade students were briefly. The fourth and fifth grade students, you know, have definitely seen exponents and factorial. So obviously for each group, finding three solutions here might be a little different. I gave you four just to bring it to life. There's actually more than four. But if you think about 7 plus 5 is 12, 3 minus 1 is 2, 12 times 2 is 24. 3 plus 5 plus 1 is 6, 7 minus 3 is 4, 6 times 4 is 24. Or we could say, well, 1 to the fifth power is 1, plus 7 is 8, 8 times 3 is also 24. Or if we think about 3 factorial, we know 3 factorial is 3 times 2 times 1, which is 6. 5 minus 1 to the seventh, well, 1 to the seventh is 1, 5 minus 1 is 4, 4 times 6 would also be 24. So those are four different ways. 13 is obviously going to be a different answer for everybody. What is the perimeter of your house in feet and inches? 14, I kind of did it in two different ways. I mean, obviously the red just says you had to know that there's 2,000 pounds in a ton. But I kind of looked at it and said, well, wait a second. If we know that there's 400 pounds when the baby's born, well, then there's 1,600 pounds left to gain. Well, if we divide that by 200 pounds a day, that'd take us 8 days. Or we could just write it out and say, okay, at the end of day one, we're going to weigh 600 pounds. Because when we're born, they're 400 pounds. We gain 200 pounds a day. So by the end of that first day, they will have gained 200 pounds. So 600, 800, 1,000, 1,200, 1,400, 600, 1,800, 2,000. So either way, you're going to get 8 days. And then the last problem on this page, what is the greatest three-digit number? Well, we have to think about it. The largest digit we can put in the hundreds place is 9. So we want to be able to put a 9 there. Well, we only have left, a 4, because 9 plus 4 is 13, and so 940 would be our largest three-digit number. When I look at the you're renting a car for 3 days, you plan to drive about 100 miles per day. The car costs $39 per day plus 8 cents per mile. Estimate the cost. You're estimating the cost because you're assuming you drive about 100 miles. That's the estimation part. So we know at $39 a day for 3 days, that's $117. We know if a car costs 8 cents per mile, right, times 100, so that's only $8 you're spending on mileage. So 117 plus 8, so it's going to cost you about $125, assuming you drive the 100 miles. Number 17, an interesting thing about 17, I know I didn't draw it to scale, it's not in inches, it's just me showing you something. If I go to draw a triangle though, hopefully what you quickly realized is, if I have a side of 12, and if my other two sides are 6 and 5, yeah, we can draw that, but the sad thing is, how is that true? Okay, and let me show you a different way to look at it. If you think about this side length, if we push this side length up, okay, and then we had that side length, so if this is 6 and that, well, let's put them in a straight line. There's our 12. If I put a 6 here and a 5 here, together that's only 11. That's not 12. So how can our two side lengths add up to a distance shorter than our hypotenuse or our other side? It doesn't have to, So that was hopefully something you discovered as you played around with it, that is, you actually, if you had a ruler in your hand and you started measuring it, you found that, wait a second, my two sides have to be greater than my third side, in terms of, two shorter sides greater than longer. So hopefully you figured that out. I went ahead and finished off 18 and 19 for you to look at. I figured 18, a book is lying open on a desk. So I'm just imagining 2 pages of the book. The product of page numbers showing 930. What are the 2 pages? So if one page was 30 and one was 31, well, we know that 30 times 31 is 930. So that could be a possible option. For the cows and geese, I wanted to show you something. So I purposely at first did it wrong. So I said there's 9 cows and 8 geese. Well, that's 17 heads. But the trouble is, if I have 9 cows, that's 36 legs, and 8 geese is 16. So that's actually 52 total legs. Well, the problem told me that I would only have 48 legs. So wait a second. What if I only had 8 cows? That's 32 legs, and 9 geese. So wait a second. If I did that, 9, 32, so that puts me at actually 50 right? Sorry about that. So that would be 50. So wait a second, let's try another one. What if we had 7 cows and 10 geese? Well, 7 cows would be 28, 10 geese would be, oh, there's our correct answer. So actually, I'm glad I re-talked that through, because I made a careless error. When I did 8 times 4 for the up here, and 9 times 2, I was saying that was 48, not 50. Actually, that's technically 50. So the correct answer would be you'd have 7 cows, 10 geese, and 48 legs. Okay, as we look at number 20, just to give you one idea, you could say 99 plus 9 divided by 9, which is 1. That would give you 100. I'd be curious to have you share with me, other things that you might have found that could have worked. When we look at the students that are in 6th grade challenge, the beauty of this is actually multiple ways you could solve this. I'm just giving you one possible solution. So if we say to ourselves, well, wait a second, 1/4 plus 1/8 is 3/8. 1 plus 3/8 is 1 3/8. If we think of 3/4 plus 1/4 is 4/4, which is 1 whole. 1/2 plus 3/4 is 5/4, which is 1 1/4. 1/4 plus 1 is 2 1/4. 2 1/4 plus 1 3/8 would give us 3 5/8. So that's just one possible solution on that one. Beautiful model drawing. So what I'm going to do with this is I'm going to walk us through to remember the steps of model drawing. I'm going to do the first problem at each grade level, and then after that I'm just going to show you the solution set for time reasons in terms of the video. So the first one, we want to read the whole problem. So Bo purchased 5 bags of cookies from the store. If each bag held 14 cookies, how many total cookies did Bo purchase? I recognize you don't have to use model drawing here. You could just multiply 5 times 14. But for pictorial representation, we'd be saying that we have Bo, and he purchased 5 bags. And we know that each bag held 14 cookies. So, if we think about it, we have 14 groups of 5, or 5 groups of 14, so that gives us a total of 70 cookies. Let's go ahead and look at number 2. Mateo and Luke fundraised for the school. Mateo fundraised $28 more than Luke, so they both start with the same unit bar. But right off the bat, Mateo fundraised $28 more. If they fundraised $78 altogether, how much money did each boy raise? Well, think about, so 78 minus the 28, so we have $50 left. That's $50 amongst the 2 boys, so that means each one of these unit bars has a value of 25. So we know that Luke fundraised $25. Mateo fundraised $53. Neat thing is about number 3, so we have Hannah, Mila, and Helene. Hannah collected twice, so we all start with 1 unit bar. Hannah collected twice as many as Mila. Mila collected twice as many as Helene, so then I had to double that. So once I double it, then we had to double Hannah's. Together they collected 35, so we find that there's a total of 7 unit bars, has to have a value of 35, so each unit bar must be 5. So how much did each collect? So then we come back and say, well, we know that Hannah collected 20, Mila collected 10, and Helene collected 5. So as you look at this, what's neat about James and Milo is that James collected 3 times as many rocks as Milo. They collected a total of 44, so we know there's 4 boxes of 44, each one's 11. With the challenge one, the wording of the challenge one's key. If Kyle has 8 more Nerf guns than Austin, we have to recognize that at this point, when they both have 1 unit bar, they have the same number of Nerf guns. So it's the 2 unit bars that represents the 8 more. So then each one of those bars is 4, so all the unit bars are 4. We know that they had a total of 16. The Mr. Harrison and Mr. Bruce, once Mr. Harrison gave away, so once he gave away 2/5, so he gave away these 2 bars. Once he gave those 2 bars away, then they had an equal number, so they both, Mr. Bruce only had 3 bars. But they started with 64 total, so there was a total of 8 bars when they started, and 8 bars have a value of 64, so each bar has a value of 8, so then we know Mr. Bruce must have had 24 cards. Now, Julia, Susie, and Sophia bought pairs. Julia bought 1/3 as many as Susie. So if they all start with a bar, Julia bought 1/3 as many. So that means Julia has 1 to Susie's 3. But then Susie bought 1/4 as many as Sophia. So if she has 3, then wait a second. 1/4 as many would be out of 12, because 3/12 is equivalent to 1/4. So we know that's a total of 32. And we find out that Julia, would have 2 pairs. Susie has 6 pairs, and Sophia has 24. So, when we look at number 8, Alexander collects antique playing cards. He picked up 1/5 of his cards in an antique store in Temple and 1/2 of his cards in San Marcos. To me, if there's a couple different ways we can solve the problem, but if we allow ourselves to look at it with a common denominator of 10, we can say that, okay, he picked up 1/5 of his cards, so 1/5, which is equivalent to 2/10, he picked up an antique store. 1/2 of his cards, so 1, 2, 3, 4, 5. 5/10 is 1/2 of his cards in San Marcos. The remaining 33 cards he got in Austin. So that means that each one of these has a value of 11. And so how many total cards did he collect? He collected 110 cards. As we look at number 9, you have to notice the difference in the wording. Because for 8, we had a reason to find a common denominator. For 9, it says, after giving 1/3 of his football cards to his brother and 2/5 of the remainder to his sister. Well, let's think about this. So, first, we had 3 bars. 1/3 of them went to the brother. So, now of the 2 bars left, we had to break that into fifths. So, we broke that into 2/5. 2 parts of that went to the sister. Then we had 30 left. So, that means each bar was 10. So, that means this lower bar had a total value of 50. That means each one of these bars was 25. So, we started with 75 cards. Number 10, Ainsley made $45. So she started with a total bar of $45. She put 1/3 in her savings. So we know that if there's 3 bars, each bar had a value of 15. So she put $15 in her savings. She spent 3/5 of the remaining. So what's 3/5 of 30? Well, if we break that into fifths, 3 parts of that. So each bar has a value of 6. 3 parts of that is 6. So $18 she spent. And the Luke and Jake. So Luke and Jake bought baseball tickets with 2/3 of their money. So 2/3 of the money went to tickets. They spent 1/4. So 1/4. So if we broke this up into as the remainder, 1/4 the remainder on popcorn and peanuts. So this 1/4 is what they spent on popcorn and peanuts. If the tickets cost $70, so those 2 tickets cost 70. So that means this is 35. This is 35. This is 35. How much money did they have left? Well, we have to think about it. So if 35 is broken up into 4 parts, well, each part is going to be, so when we think about the 35 broken up into 4 parts, each one of those bars is $8.75. But we got to remember, one of those things we bought peanuts and popcorn. So how much money did they have left? Well, they had 3 bars left. Each bar is $8.75, so they had total $26.25 left. So as we look at Bo, had $1,600. He spent 3/8, so we have 8 unit bars. He spent 3/8 on skis. 1/4 of the remainder. So when I created a second unit bar, because we had of the remainder, so we know we had 1/4 of that. So as we break it down, we find out that he spent a total of $600 on skis, $250 on gear, so he spent a total of $850. There is 560 boxes of Girl Scout cookies that need to be sold. So of the 560, 2/7 are Thin Mints, so that's 160. 1/5 of them are tag-alongs, that's 112. But if we add those together, that's 272. And we know that 1/3 of the remaining, well, we have 272 cookies. Now, if we let them be the remaining cookies, okay, we find out that it would be 90 and 2/3. What I'm hoping, though, is if you did something like this, you would say to yourself, wait a second, how can I have 2/3 of a box of cookies? So we'd go back and say, well, wait a second, no. 272 was the total number of cookies between the Thin Mints and the Tagalongs. Wouldn't we have to subtract 560 minus 272? And that would give us 288. And then what's nice about that, if we think about 288, well, 288 divided by 3 would give us 96 in each box. So hopefully if you made that error where you took the 272 and you said, wait a second, I can't have 2/3 of a box, hopefully you double checked yourself. And then you found out, well, how many Samoyeds do you have? Well, technically you have, it's 288 divided by 3, so there's actually 96 Samoyeds. We know that 2/3 of Teddy's weight is equal to 2/5 of Robbie's, so we said 2/3. So we created our thirds box, we're going to 2. But 2/3, so these 2 bars are equal to Robbie's 2 bars, which is out of 2/5. So we find out that each one of Teddy's bars has a value of 40, that means Robbie's bars are at 40. So if we don't know how much does Robbie weigh, well, we know that Robbie weighs 200 pounds, because he has 5 total bars of 40. What's neat about the challenge problem is it really is a before and after problem, which really, to me, makes it the challenge. It's not, it could be the ratio part, but to me it's more recognizing the before and after. So Ty and Harry collect Civil War books. Initially, Ty has 6 times as many as Harry, so Ty has 6 boxes, Harry has 1 box. But then after Ty gives him some, so they have a ratio of 9 to 5. So if I allowed myself to break those initial boxes in half, so instead of Ty having 6 total boxes, he has 12, and Harry has instead of having 1, he has 2. Because then by having 12 boxes, it's much easier to give myself that ratio. Because if I gave 3 boxes away, that gives Harry 5, and that leaves Ty with 9. And then we know that we say, well, okay, well, if Harry has 5 boxes, Ty has 5 boxes, there's 4 extra boxes Ty has. Those 4 extra boxes have a value of 12, so each box must have an answer of 3, and then it allows us to break down the problem to find out that we know now that in this situation, it says, how many Civil War books did Harry have initially? So Harry had 6 books initially. And then once he was given books, we can answer that question too, but that's obviously not one of the questions that's being asked. The numeracy and computational strategies, I'm actually going to send this as a separate video because I just don't have enough space to be able to share multiple strategies with you. So I will be sending this as a separate follow-up video. Thank you.